And I'm going to back up just a second. This is number 3. So I'm going to back up just a second and pretend that it was given to us like this. And then it becomes 0. The y value becomes 0. Because, again, what that's saying is, if you write that, or if you get an equation set equal to 0, you're saying, I want to know the x values when y is 0. And that's what that says. So now we have a few options to deal with. If we can get it factored, we can set each of those factors equal to 0, and that's how we're going to do this one. So how does this factor? Yeah, they have a greatest common factor of x cubed. We take that out, what's left over? But just plus 4, right? Okay, so since we have something factored equal to 0, we can set each of those factors equal to 0. Now, how many solutions are we looking for right now? Why? Because the biggest exponent's 5. Okay, so right on this first one, we're going to take the cube root of both sides. What's the cube root of 0? But we were supposed to get 3 answers out of that. So is this okay that we only got 1? Bless you. Well, okay, so this is multiplicity of 3. And so basically all that, you could write x equals 3 times, or I'm sorry, x equals 0 3 times if you wanted. But basically the idea is to say, oh, it's okay that 3 of my answers are all going to be 0. All right, so this is 3 answers because this is a, like if you want to use the terminology, right, this is a multiplicity of 3. How do we solve the other one? Subtract 4, so then we got x squared equals negative 4. Square root, when you take a square root, you better get a positive and a negative. Now what? What happens with the square root of a negative? And then what's the square root of 4? So then we got 2 solutions there, right? And notice that, well, hopefully you've noticed this, but anytime you're dealing with a square root and or an imaginary number, they always come in pairs. Okay, you can never have one without the other when you're talking about roots. We're going to talk more about that here in a second. Bless you. All right, so that's all 5 of them. Is that okay? So is there anything else we should do from 1 to 15? You know, I'm looking through this 5, 7, 11, 15 are all some version of A times C. Some a little bit more than others. 9 is the sum of cubes. You have to have that formula memorized. 13 is the difference of squares. Is there any more we should do from that? So again, they've already set the y value equal to 0, so we're finding x values here. How many solutions should we find? 2. It factors, but what's our other option? Well, okay, so it factors, we would do A times C, but what's our other option? What is it? Quadratic formula. You can do quadratic formula too. What do you guys want to do? All right, so then x equals what? Well, we're doing the quadratic formula right now, right?
Oh, square root of.
I don't know. Uh-oh. What is the quadratic formula? Here, let's write down the quadratic formula. What is it? Just the formula. Negative b
Square root of b to second.
plus or minus square root of what?
B squared minus 4 times a.
All over 2a. I would know that. All right, so then what's, we're using this, what is it?
5
5.
plus or minus squared. Or negative 5 squared.
Which is 25. So minus 4 times negative 3 times 8. All over negative 6. Can I write it like that? All right, so then what? $25 plus 96. What was that 121? So, all right, one of them is 5 plus 11, that would be 16 over negative 6. So I believe that reduces to negative 8 over 3, right? And then the other one is negative 6 over negative 6. Did we get 2? What kind of solutions are those? Real. What kind of solutions were these over here? One real, 2 a complex or imaginary? Yep. All right. Is that okay?
No.
Well, not do you like it, it just doesn't make sense.
Yes, sir.
All right. All right, so then let's look at 17. Okay, it says, state the possible number of positive real zeros, negative real zeros, and imaginary zeros for each function. The idea is that we're narrowing down, trying to help us figure out what these zeros are. And you don't want to just go blindly into it, right? You want to have at least like some kind of place to start. That's why we're going through all this. So we're looking at sign changes. So how many sign changes are there? So there's 1, 2. So 2 sign changes. So what's that mean for our positive zeros? Or, so 2 positive zeros, or, so you always get that number and then subtract by 2. All right, so then there's 2 positives or there are no positives. Is that okay? Now we have to check out to see how many possible negative solutions there are. And so then we're going to evaluate this function, except that we're evaluating it now at negative x. And so how does that change things? Which signs though? Not all of the signs. No, not all of them. No. That has something to do with the exponents. So the even, okay, so we're plugging in negative x. So all the even exponents stay the same. All the odd exponents change. So then it would be negative 3x cubed minus 4x squared plus 17x plus 16. Is that okay with everyone?
Only one sign change.
So now we only have one sign change. So what's that tell us?
One positive 0.
Well, we're on negatives now, so one negative 0.
One negative, yeah.
And so for sure we have one negative 0. One negative real 0. All right, so how many total are we looking for? 3. Okay, so we could have positives, we could have negatives, or we could have complex or imaginary ones. So we could have 2 positives. We have to have 1 negative. So how many imaginary would there be? 0. Or we could have no positives. We have to have 1 negative. So 2 imaginary. Is that okay? Those are our only options. Is that good? Should we do another one? We're going to do this more, so. Okay. So that's okay. So you're responsible for 1 to 27. If you can do tonight's homework, like this whole section, you can do this whole section basically. There'll be a little bit more tomorrow, but basically today's is the big deal. So we're coming back here. We're on page 285. All right, and the first thing they're going to talk about is complex conjugate theorem. I've already described the complex conjugate theorem. So you're welcome to read that, but I'm going to summarize everything here, which says complex solutions come in pairs. Okay, and so what that means would be you cannot just have an A minus BI. You would have an A plus or minus BI. They come in pairs. You cannot have an odd amount of imaginaries. That's all that stuff says right there. Is that okay? So the idea would be that we find one, we go through all these techniques and you find one and you're just like, sweet, I just found 2 actually, because that one's imaginary. Okay? All right, so here's what we're going to do. This is the big example for today. Use synthetic substitution to find zeros. What the heck's synthetic substitution again? It's basically using the remainder theorem. So what's the remainder theorem say? Well, I guess and the factor theorem. One of the two. We're using both. So right, if you run through synthetic division with a value, and the last number, the remainder is 0, what's that tell you? Tells you 2 things, really. But the main thing is that thing that you did, the thing that you worked with was a 0, because it gave you a 0 at the end. The other thing it does is that remainder is what the function would be equivalent to if you evaluated at that number in the box. So it's telling you 2 things. Okay? Synthetic substitution, synthetic division is very quick. That's why you do it. So let's find all the zeros here. How many are we looking for? Why?
That's the biggest exponent.
It is the biggest exponent. Is that okay? All right, let's go. All right, we don't want to go blindly into this. We're looking for 3 of them. We don't want to. We want somewhere to start. So we want to check out, see how many positives and negatives we got. So how many sign changes are there for the positives? That's this first one.
1.
1 sign change. So how many positives could we have? One. We have one sign change, so we have one positive real zero, right? That's for sure. That's nice. Helps. Right? Then we evaluate it for negative. How many sign changes are there now? Two sign changes. So how many negative real zeros do we have? Or could we have? 2 or 0. Okay? So now I'm going to make that chart like we've been doing. So we could have positives, we could have negatives, we could have imaginary. So how many positives are we definitely going to have? 1. We could have 2 negatives. If we had 2 negatives, how many imaginary would we have? Why? Because there's only 3. All right? We have to have 1, but maybe no negatives. So that would mean 2 imaginary. Okay, we're narrowing it down. We're trying to figure out like some things here. We know we have 1 positive, which is super nice. Okay, so the other goal that we have on this is we want a kind of a rough sketch of this function. So this next chart is kind of confusing. And also, I'm going to explain a little bit what's going on, and then I'm going to explain like things that I would do if I was you. Okay, so the first thing is, what the heck is this chart? Okay, so I want you to look at our original up here. Okay, and notice that the coefficients up there are 1, 1, -7, -15. Right? 1, 1, -7, -15. Okay? So then they're doing synthetic division, and they're just doing it all at once. Okay, they're not going through the steps, they're just showing what it became. You would have to do this. Okay? Especially before graphing calculators, you'd have to do this. All right, so then basically what they did was they did synthetic division with each of these numbers. Now, in some ways, this is pointless. I'm gonna have a side comment here in a second. Okay, but in some ways it's pointless, and that part I'll explain. But the other thing that it's doing, if you understand what synthetic substitution does for you, is that it evaluates that function. So this last column is your remainder column. So again, you would never be able to, well, I mean, I guess you could, but right, you'd have this written out a couple different places. You have to go through it. This is just the answer to each of them when they do it. Okay, so basically what they said here was, if I evaluated -3, I'd get -12, not a 0. If I evaluate at -2, I get -5. Again, not a 0. If I evaluate -1, I get -8. If I do 0, I get -15. If I do 1, I get -20. If I do 2, I get -17. Look, I get 3 and it's a 0. That means that's a solution. And then if I do 4, I get 37. So is that okay, what this chart is? Now they're going to use this chart here on this next step, on step, or part B, to make a rough graph. Because they're going to say, oh, I know these coordinates now. Because this first one is -3, -12. This next one is -2, -5. Does this make sense? And so then they're going to plot all these. So there's but really this is the big one right here, because this is going to be super important. 3 is a 0 of the function. That's super important. Now I don't know the explanation of this, because they're kind of just turning you loose, and it's like, I'll just grab a bunch of numbers and start plugging them in. And it's okay on this because we're going to end up graphing it. But if you're asked to find the zeros, a lot of these make no sense to do. And so there's another theorem, and again, I don't know why we haven't talked about this theorem, because to me it makes sense to do it right now. There's another theorem that goes like this. Think of all the factors of the coefficient of your first term. 1. So it's just 1 and 1. Is that okay? And then think of all the factors also of the last term. So like all the factors of the last term would be like 1 and 15. One could be positive, one could be negative. 3 and 5, one could be positive, one could be negative. Because again, we're trying to narrow it down, and someone along the way, I can't remember who it was, figured out like this is how it works. So remember, this one is just 1 and 1. And so then they're saying if there are real zeros, they have to be some combination of these divided by these. So you can have a whole bunch of them. Okay, so this is not how I would do it. Since they're not asking you to do it, I wouldn't do it this way. But this is, what my point is like, I don't know why we're testing all of them. It doesn't really make any sense to me. Okay, so the only options for real zeros would go like this. It could be 1 over 1, negative 1 over 1. It could be 15 over 1 or negative 15 over 1. It could be 3 over 1 or negative 3 over 1. It could be 5 over 1 or negative 5 over 1. Those are our only options. So when you come back to this chart, if you're just looking for the zeros, some of these make no sense. So like negative 2, like you wouldn't test that one because there's no way it was going to be a real zero. You wouldn't test 0 because it wasn't going to be a real zero. You wouldn't do 2 or 4 either for the same reason because it has to be part of that chart or that thing I just did. The only way it's going to work is it's going to be one of these. Okay, so what I would do is I would graph it and find the 0 because you know there's going to be one of them. And so then you find 3. Okay, so that's how I would do it. And we're going to do an example and we'll go through it, okay? But I just wanted to explain why all this is going on because now we can plot these points also. All right, so then looking at the 3, the one that's a 0, does it make sense if this is the answer that this would now be the equation 1x squared plus 4x plus 5? Does that make sense? And so then they're saying, look, there it is. That's our depressed polynomial. So now we can solve it. That does not factor. So you'd have to do the quadratic formula. The quadratic formula, the answers, they got them right down here, right? Negative 2 minus I and negative 2 plus I. What's going on? Is that okay? All right, and so then they say down here, the function has one real zero, so make sure you plot that. So there it is. And then it says, it's not going to cross the x-axis any other place. We know that because we just found the other 2 zeros, and they were imaginary. So it's never going to cross anything else. And then they say some stuff that we did before. So the degree is odd. So it's basically going to be some version of this shape where the first coefficient is positive. So it has to be that shape. We talked about this, and it's been a while. All right, and so then they're saying, so then I know because it's odd, because the first coefficient is positive, that as x goes to negative infinity, y is going to a negative infinity. Right, and when x goes to positive infinity, y goes to positive infinity. Is that okay? And so then it's going to be that general shape crossing once, and then they're going to use all these coordinates that we could come up with over here to make this other sketch, the rest of that sketch. But again, you got a graphing calculator, you got to answer the questions you're being asked, but you can find a lot of these by just going to the graphing calculator. Is that okay? All right, so then 1A is basically the whole chapter. I mean, essentially you can do the whole chapter if you can do today's homework, okay? Because it takes care of almost everything we've done. So determine all the zeros of this function and use them to sketch a rough graph. So I want to start with how many possible we have. So how many sign changes are there right now? 1. So 1 sign change. What's that tell us? For sure, right? 1 positive, for sure. All right, so then we got to look at f of negative x. How do you know if a sign changes on this now? If the exponent's odd. So does the first one change? Does the next one change?
Yes.
Does the next one change?
No.
Does the next one change?
Yes.
And then if there's no variable, it never changes. So how many sign changes are there?
2.
Careful. I think there's 3, isn't there?
Oh, 3, yeah.
Yeah, okay, so then with the negatives, so there's 3 sign changes. So then what's that tell us for our negatives?
It's 3 negative.
3 or, you always subtract by 2.
1.
So 1, 3 or 1 negative. So is this okay with everyone? Because again, if you can do this, then like basically the whole chapter is, you can do the whole chapter. So 3 or 1 negative. Is that okay? All right, so I like to make a chart, like to get all the things that we need. So, right, we have a positive, we have a negative, and we have imaginary. How many are we looking for total?
4.
4. Okay, so we have to have 1 positive. How many negatives could we have?
3.
So if we have 1 positive and 3 negatives, how many imaginary?
None.
None. We have to have 1 positive. What's our other option for negatives? 1, which would leave how many imaginary? 2. They always come in pairs. Is that okay? All right, so now what they want you to do is to just grab a bunch of numbers and start doing synthetic substitution with it. Totally can. But I would think of factors of negative 80. That's how I would do it. But you could also graph it on a graphing calculator. So someone do that and tell me what the zeros are.
The regular one?
Negative 4 and 5. Okay, so that's our 2. We know that for sure. And how did you get negative 4 and 5? Yeah, it's on like you just like you graph and you look at it, right? So then, since you did it, is there any other place that it crosses the x-axis? No, she got them all, right? And so then notice that we're in this one, right? 1 positive, 1 negative, so that means we got 2 imaginary numbers. Now, we got to get our depressed polynomial. There's no other way to go about this. So negative 4 and 5, we're going to do synthetic division with both negative 4 and 5. Which one do you want to start with? Fine, negative 4. Why are we picking negative 4?
Just the first one.
Yeah, and she found it crossing the x-axis, right?
Mm-hmm.
Where are these numbers coming from?
The original coefficient.
These are the coefficients of the original. All right, so let's go through it. What does it give us? What's supposed to happen here?
Or 0.
We better get it remain a 0 or otherwise something went wrong. Yeah, okay, so what's going to happen here?
1 down.
1.
Negative 4 times 1, which is negative 4. And add negative 5. Negative 5 times 4 is 20. Add again, negative 4. Negative 4 times 4 is negative 16. Add together is negative 20. And negative 20 times negative 4 is 80.
And 0. Okay, so it did work. Okay, so really what we have now, because we started with a fourth, we have a x cubed minus 5x squared plus 4x minus 20. Okay, but we can't handle that either. Luckily for us, she already told us the other one. So it's 5. Now don't go back to the original because you'll never get something that you can handle. So I'm just pulling off these numbers again. You know, so to be clear, you don't have to rewrite this one. You don't have to do that because we can't handle that anyway because we started with a fourth. It all depends on what you get. But same kind of thing, this should give us a 0 at at the remainder, because we're saying this is another 0, so let's do it again.
Five times one is 5, and the other is 0. 5 times 0 is 0, and the other is 4, and 5 times 4 is 1.
And then there it is, it's 0. So now we have x squared plus 4. I wonder what's going on. Got a doctor's appointment. All right, so that's set equal to 0. Subtract the 4 over. So our other two answers are I, so then square root of 4 is, so then plus or minus 2i. Okay? So then these are the imaginary, right? We found everything we needed. Negative 2i and 2i. Okay, now we don't have a big chart like we did on that last problem. But you got a graphing calculator that does an XY chart for you, so you can get the rest of this graph. Okay? I know it's going to, some things I know, it's going to cross here and here. I know the shape of a x to the fourth, it's like a W. I also know it's not going to cross the x-axis anymore. So I don't know exactly what it looks like, but it's going to look something like this. Okay? Now your graphing calculator can get all of that for you to get it more exact. And they may ask that, okay? All right, so any questions? Should we do any more? Should we do any of your homework? Because all your homework now, you're responsible for 1 of 27, but now it's just 29 of 39. I adjusted that. So is there any, should we do any more? Are you guys happy? You know what to do? I'll take out as happy.